So for today's lesson, we are going to talk about our special cases of linear systems. So far, I've taught you all three methods of solving systems. You can graph, you can substitute, or you can use elimination. But sometimes, we're going to have special cases where you're not going to get that one value for X and that one value for Y. So this lesson is going to explain to you what to look for, and when you identify these special cases, what the answer will be. There's two types of systems that will give you special solutions. These are your special cases. The first is your inconsistent system, okay? An inconsistent system is a linear system of equations with no solution. Now, we've heard of no solutions before, okay? So that's what makes it a special case. We're used to our systems having an X value, a Y value. When your system is inconsistent, that means you don't have either. They don't exist. It doesn't mean that X is 0 or Y is 0. It just means that there's no solution. And I'm going to show you how to recognize when you have an inconsistent system. So let's talk about how you have one when you're graphing. What does your graph look like when you have an inconsistent system? Well, the first sentence says an inconsistent system will have, let's see if I can move this over a little bit. Where am I going? Right there. Parallel lines, okay? They never intersect. You know that's what parallel means. They are two lines that never intersect. Well, if they're two lines that never intersect, then there's never going to be a point of intersection. There's your no solution. So that will be an easy one to recognize, all right? Now, if you're looking at, you just want to eyeball the equation and you don't want to graph, here's what you would look at for the equations. The lines will have the same slope. Okay, so if you look at your equations and your M is the same, that means that the lines are parallel, there's no solution. Or they will have no ordered pair in common. Now that should make sense to you, because if there's no point of intersection, then there's not going to be an ordered pair in common. So you need to write this down, because when you graph and this happens, that means you have no solution. Your lines will be parallel and you will simply write no solution. Now, what happens if you are substituting or using elimination? How will you know that you have an inconsistent system? Well, here's what you look for. First of all, your inconsistent system will have both of your variables cancel out. All right? Everything, X and Y, T and P, M and R cancel out. And you are left with a false statement. What does a false statement mean? That means that when all of your variables cancel out, you're going to be left with something like 0 equals 5. You know that's not true. That's a false statement. So when this occurs, that means that you also have an inconsistent solution. So make sure you write this down, fill in your blanks, because this is what you'll need to know to identify